Hello everyone. So welcome to this video. I'm starting from where we stopped in our lives class. So we stop at question number 37 under function of a variable and graph. So the next question here on screen is we are asked to find the domain of this two piece function. That is that this only works when s is less than 3 and this work when s is greater than or equal to 3. So we are asked to find the domain, that is the set of all inputs you can put here. Do you get it? So let's start with the first equation. The domain of a function that is having square root is that when the function inside the square root is actually greater than or equal to 0, because that is when you can take square root of 0 and you can take square root of positive number. So any of the two is going to work inside square root. But anything less than 0, negative number, cannot you cannot take the square root of it. So meaning that the inputs, like what is inside the square root, which is s plus 1, must always be greater than or equal to 0. So s must be greater than or equal to minus 1. But mind you, this function only works when s is less than 3. So meaning that even though s is greater than minus 1, if we use any value that is greater than minus 1 but is not less than 3, that means that this equation cannot work in the first place. Do you get it? So meaning that even though s is greater than minus 1, then greater than or equal to minus 1 because of this square root, s must also be less than 3 before this equation can work generally. So that means s is starting from minus 1, because this is how we just know it. Greater than is going in this direction, so we should start from that thing that is greater than, and then is less than 3. Less than is going in this direction, so from 3 to left direction. So that is how we know it. So and then mind you, minus 1 itself is included, so you use this kind of brackets, but 3 is not included, you use normal brackets. So this is the domain that works for this first part. Do you get it? So you find the domain that works for the second part as well. So when x is actually greater than or equal to 3. So of course we see that this function has a denominator, and once the denominator is equal to 0, then the function itself is not defined. Meaning that you can have every value all real number except when this s is equal to 3, and s minus 3 is equal to 0. So what is s minus 3 must not be equal to 0, right? Meaning that s must not be equal to 3. So normally this equation will works for every number that is greater than or equal to 3. So normally it was supposed to be it's starting from 3 and it's greater than, right? So it's going like this. So it's starting from 3, then it's going in the positive infinity because it's approaching a positive number because it's greater than. So and then it's approaching infinity. So it was supposed to be like this. But this function explicitly rejects s to be equal to 3. Even though s is equal to 3 is part of the domain for this function, then you have to omit it because of this condition. So you change the bracket to this. So the first one is minus 1 comma 3. This one is this. So that means that this one will work for this one and this one will work for this one. The meaning is that is either this is a domain or this is also a domain. Like this and this are domain. Do you get it? That is when you use union. But if you say it's intersection, that means that this must be achieved and this one must be achieved at the same time. Meaning that for every value of x, it must fall within this range and fall within this range as well. But that is not the case here. This case here is that it's either this one works if this between any number between this and this will work, and at the same time any number between this and this will also work. So it's a union, like this set A, this set B, the union of the two. So meaning that B is actually the answer. So let's move to the next question. We are now asked that the function f of x is equal to x square is decreasing on. So normally this is how our quadratic graph x square looks like. So normally in this positive side, when your y is equal to 1, your x is also a positive number, maybe probably 2. When you increase your s to 3, you should be expecting 9. Can you see? You are is following a positive stuff. The more you are increasing your x, the more your y increases. But this one, when you increase your x like this, okay, let me say when you increase your y, let me use y. Sorry. When y is equal to 1 like this, okay, this one was supposed to be 4 sef, because 2 square is 4. So let's say this phase like this, when y is equal to 4, x is actually equal to -2. And this is when you do -2 square, you get 4. And this one, when it is -3, that is when you get your 9. Sorry, it's not touching the graph. It's because of the way I drew it. Do you get what I'm trying to say? In essence, is that when your s jump from your y jump from 2 to 9, 4 to 9, meaning that it increased from 4 to 9, what happened to your x? It changed from -2 to -3, and of course -2 is greater than -3, meaning that it's decreasing on the y-axis. So you don't need to draw the graph, just need to picture it in your head, or just test value direct. Write any two negative number, then experimentate, square it. This one will give me 4, this one will give me 9. So write two positive number as well, experimentate is 4, 9. This one from -2 to -3, -2 is bigger, -3 is less. Do you get it? So it's decreasing. So what happened to your 4? From 4 to 9, that is increase. So this is a decrease, is decreasing at this point, the negative side. There's this one. This one is from 2 to 3, that is increase. This one also from 4 to 9, that is also increase. So both of them are increase, meaning that on the positive x-axis is going to keep increasing, but on the negative side is going to be decreasing while the other is increasing. So negative number, how do you represent negative number? S is less than 0. And how do you write that? It's starting from 0, is going in the negative side, then it's approaching negative infinity. Negative infinity is not a number, so it's not included. And 0 also is not included because 0 is neither positive or negative. So 0 itself is not included. So that is why A is our valid answer. So moving to the next question. The function is increasing on, so we can still use the same approach. Pick two negative number to test to make it faster. -2 square is going to give me 4. Remember, there is one minus here before, so that will be -4. That is that when I first do -2 square, it's just like saying minus into bracket -2 square. I first do -2 square, I get 4. Then I put negative in the front. -3 square is 9, and I put negative in the front. I test the same value with 2 and 3. So 2 square is 4. So when I put minus, that will be -4. 3 square is 9. When I put negative, it become -9. So now let's check the trend. -2 to -3 is actually from -2, a bigger number, to -3, a smaller number. So it's actually decreasing. Let's check the trend here too. From -4 to -9, -4 is bigger than -9, so it's also decreasing. So for 2 to 3, that is an increase. -4 to -9, that is a decrease. Meaning that in the positive end, this function, when your s increase, your y is going to decrease. But this one, they're asking us that which one is increasing. So this is automatically out. So this one is decreasing when this one is decreasing. That means that if you increase, this side will also increase as well. So the negative end makes the function to be increased, this function. So if it's a negative end, so x is less than 0. So you also write it the normal way. You should write it from negative infinity to 0. Then that is A. So moving to the next one, which function is increasing for all real x? So you can test, that is, for every positive number, which function always increase. So though I knew that my answer is not s square. S square is always like this. So I already know that is wrong. Minus s square too is wrong. The only difference is that the decrease happens at the negative side. We have done this already, so we already know they are out. So it's for us to now test this and this. Of course, this is also wrong. This is correct. How do I know? You can do that. If you are not familiar with the graph, you can actually test value. for the positive end, we always get an increasing value. So let's test for x cube. So in the positive end, I test um x cube, right? So let me test 2 and 3. So 2 cube will give me 8, 3 cube will give me 27. This one from 2 to 3, that is increase. This one too from 8 to 7, that is increase. So if you keep on doing the same thing over and over again, you'll be getting an increasing value in the positive end. Do you get it? And let's test the negative end as well. -2 and -3. When you do -2 cube, you are going to get -8. And when you get -3 cube, you get -27. So this is actually a decrease from -2 to -3. So from a negative number to a more negative number, which means a more negative number is actually smaller. Do you get it? So this is a decrease. This one too, from a negative number to a more negative number, that is also a decrease. Meaning that if x decrease, y will also decrease. So decrease means that if x actually increase, y will also increase. So this, both the two end, they're actually giving a increasing function. Do you get it? So that is why this is actually a valid. But that absolute value of x falls within the same category with, sorry, so it falls within the category of these three. So even though you try absolute value of x, absolute value of x will actually make a negative number positive, meaning that even is a more negative number will become positive. So a more negative number is actually smaller, but because of absolute value is turning into positive, it will become bigger. So what is the point? So it's actually um increasing the function even when the function is decreasing, meaning that it's not increase, it's decrease vs increase. So question here. So okay, I've not picked my answer. Let's give this answer. We are moving to the next one. The graph of fx is equal to this as the minimum at. So you can do it in two ways. You can actually differentiate, but for quadratic equation is something very easy to do. Just take this -4, write it. If it's having minus, remove the minus. If it's not having minus, add minus. Do you get it? So remove the minus, then divide it by 2. That will give me 2. So the answer is 2. But if the coefficient of this x square is not 1, then you divide by the coefficient. Of course, the coefficient is 1. So if I do 2 divided by 1, it's the same thing. So that is why I ignore that. But once it's not equal to 1, you have to divide it by the coefficient. So 2 is the answer here. So the answer will be 2. And you can decide to use your differentiation. You just differentiate it and set it to be equal to 0. So x squared is 2x when you differentiate it. -4x is -4. Then 7 is a constant. It's out. So it's equal to 0. Then you say 2x is equal to 4. Then you divide by 2. So of course x is equal to 2. The same result. So C is actually the answer. So moving to the next one, I have the axis of symmetry of this function is what? So what is the meaning of axis of symmetry? When you have a quadratic graph like this, you have a quadratic graph like this, then it looks like this. If you notice very well, this line, sorry, my quadratic graph is not perfect. So this line is a line that cuts the parabola into two equal parts. That is, this side and this side are equal to each other. So it's just like trying to cut a rectangle into two parts. There is the axis that can cut the rectangle. It's not just ordinary line. You cannot use this line to cut it into two equal parts. Just exactly this straight line, we cut it into two equal sides, meaning that this, at this point, the graph is symmetry in the positive and the negative end. Like the shape are the same. Do you get it? So what that implies is that the line, that line, we want to find the equation of that line. Do you get it? But one thing interesting is that this is always passing through the minimum point, the sharpest point. Or if you say the graph is maximum and it looks like this, it will always pass through the maximum point. Meanwhile, it's not necessarily that it's passed through the center. So even in fact, this function is not, the minimum point is not at the center, it's not like, it's not at when s is equal to 0. It shifted a little bit, but I'm not really concerned with that. So let me just get my answer and let me move. So, and then that means that if we find our minimum point and we know our line passed through the minimum point, And another thing is that our y is a vertical number. For a vertical number, it means that for every value of y, x will be constant. That is that it does. You can see this graph like this. When y is equal to 2, x is on the same place. When y is equal to 3, x is on the same place. So you can define a particular number by saying x is equal to just one thing. That one thing defines it. Why it does not depends on y at all. That is a vertical line for you. So what this implies is that once you can know the x coordinate of this point, that x coordinate is going to apply for all the whole vertical line throughout. So, and to get the x coordinate, we can find the x coordinate of our minimum point. So we can actually use two methods. It's either we differentiate or use the other method. This is -8, the coefficient of x. You remove the minus, then divide by 2, that is 4. Your result, because the coefficient of x square is 2, then divide it by 2. So that will give me 2. So meaning that my minimum point is actually 2. So that means that for every point that s is equal to 2 that is where the vertical line pass through. Do you get it? So, and then this other method, you can use differentiation. 2x squared, that will give me 4x, minus 8x, that will give me 8, equated to 0. Then divide by, okay, take 8 to the other side, it's become plus 8, then divide by 4. So 8 divided by 4 is going to give me 2 as well. That is x equal to 2. So this is why this is my answer. And mind you, don't forget, if you are using my trick, if minus is there, remove the minus. But if minus is not there, I'm emphasizing it. Put minus if minus is not there. Do you get it? So B is the answer. Let's move to the next one. I have which of the function is even. So I've mentioned something related to even in my previous video. So let me just do a recap. So when you said even function is a function, is originated from the fact that when you have polynomial of x and the power is even, like x raised to power 2, x raised to power 4, x raised to power 6, they always follow one condition. And what is that condition? That when you do f of x and you do f of minus x, you are going to get the same result for and this kind of function that their power is even. Let's test it. When you do 2 square, of course you are going to get 4. When you do minus 2 squared, you are going to get 4 as well. So that is what this grammar is trying to tell us, that when you input a x there and you put another input there, it's just the negative of this x, you are getting the same result. That works for x square. The same thing works for x raised to power 4 and like that. But we discovered that not just although that is where the name is originated from, but not just those functions. There are other functions that are actually even as well, like cosine and the likes, and you can actually group polynomials together, and at the end of the day they will end up being an even function. So and we an odd function. An odd function is a function that like polynomial with x raised to power 1, like with odd number like x raised to power 1, x raised to power 3, x raised to power 5, and they all follow this function that this they follow this rule that f of minus x must be equal to minus f of x. What does it mean? That if I take minus x, I find the function of minus x for that function. I now remove the minus, I put the minus in the front, I now find f of x. I should get the same result if it is an odd function. So what will I do? I'll test that. So let me pick like x cube. Let me do minus 2 cube. Of course, minus 2 cube will give me minus 8. Oh yeah, let me do 2 cube. That will give me 8, and let me add minus in front. Minus 8 minus 8, the same result. It follows this rule, so it's an odd function. But there are other functions that are not just an odd function. Like they are not just power of odd number for polynomial. We have other functions like sine, many like that. You just need to test them and you are good to go. So let's now look. S cube is actually an odd function, meaning that when you do this s cube, when you do f of x and f of minus s, this should be negative here, this should be normal here. So what does this implies? So it means that but the best thing you can just do, so to keep or not interpreting too much. Just input a value. This minus 2. Let me first use minus 2. Minus cube will give me minus 8. And s is minus 2. That will give me minus 10. Then use s is equal to 2. So 2 cube is going to give me 8 plus 2 is going to give me um 10. This one give me minus 10. This one give me 10. So I do f of minus x. I do f of x. This one give me 10. This one give me minus 10. So that means they are not even function because they did not give me the same thing, but they are odd function because one is positive, the other is negative. But we have to find even function. So this is an odd function. So for s square, if you do 2 square plus 4, that will give me 8. When you do minus 2 square plus 4, that will give me 8 as well. So it's an even function. So, but you should know s square is even function. So this 4 is not affecting it. So, but for odd function, if your odd function have a constant in front, they will not give you the same thing because how will I explain it? It's just like saying s cube plus 4. This s cube is an odd function. That is that this one can be minus. Let's assume this one is minus 8 when you use minus 2, and this one is plus 8 when you use plus 2. Do you get it? If you add 4 to this one and if you add 4 to this one, this one is going to increase. They are both increasing, but this one is going to turn from minus 8 to plus 4. That will give me minus 4. This one will be 8 plus 4. That is give me 12. So there are different numbers now. So once you add the constant to an odd function, it's going to become is neither even or odd again. Do you get it? So take note of that. Well, B is actually our answer. So let's be fast with that. So let's move to the next question. Which function is odd? So of course, I know my s cube is odd, and I also know that my 2x is also odd, but because of that minus that is there, that is giving me concern. But the best thing is to test. I think it should also be odd. A node function plus a node function, yeah, is a node. So let me just confirm sha. So let me use minus 2. So when you do for minus 2, when you do minus 2 or gives power 3, that will give you minus 8. Then minus 2 times 2, minus 2 times minus 2 will give me plus 8. That will give me minus 4. Then test for 2 as well. So when you do 2 cube, that will give me 8. Then minus 2 times 2, that will give me minus 4. So 8 minus 4 is 4. For f of minus x is minus 4, f of x is 4. So this is actually an odd function because if f of x give you 4, if you do minus f of x, you are going to get minus 4 like that. So it's an odd function. So of course A is the answer. So moving to the next one, determine whether this is even or odd. So first of all, denominator. If something should be even or odd, the first thing you should test is you can test value directly, but you can also at least test the denominator. Once the denominator is constant, do you get it? That is, the denominator is even function or is a constant value. Just test the numerator. If the numerator is now even, then you know that it is even. And if the denominator is now odd, then you know that it's odd. First test if minus x is going to give you the same thing. So if they are giving you the same thing, so you just need to check this numerator that is it also giving you the same thing. But once the numerator, even though the numerator is giving you the same thing, the denominator is not giving you the same thing. You cannot predict it because 1 over 2 and 1 over 3, they are quite different. So but just to make it easier, let's test value. But of course this s is an odd function, so everything is odd function. But let's just test value. Let's use 2 and minus 2. So in this case, when I use minus 2, that will be minus 2 all over minus this s square will be minus 2 square, that will give 4 plus 1. So that will be minus 2 all over 5. Then 2, that will be 2 all over 2 square is going to give me 4 as well. 4 plus 1, that is 2 all over 5. Can you see? This one is 2 all over minus 2 all over 5 for f of minus x. For f of x is 2 all over 5. That is an odd function. So B is the answer. So you are asked to find f of g of x. This notation is meaning that f of g of x, that is something like this, a composite function. You get it? So what is f of x itself? This is f of x. So now you are replacing this input, which is x, with g of x. So of course f of x is equal to 2x plus minus 1 before, so it will become 2 of g of x minus 1, like your s change to g of x. So what is your g of x? S square plus 3, then minus 1. That will give me 2s square plus 2 times 3 is 6 minus 1. So that will give me 2s square plus 5. So A is my answer. And then the next one, I should find g of f of x. So that is g of x itself is 3x, 3x plus 2. So g of f of x will now give me, I'll replace this x with f of x. So that will be 3 into bracket s square minus 1, then plus this 2. So 3x square, that is 3x square. 3 times minus 1 will give me minus 3 plus 2. So minus 3 plus 2 will give me 1. That is 3x square minus 1. So B is actually equal to the answer we got. So we should find f of A is equal to 1 over 2. This is quite easier. So that is when my input is A, my output is actually 1 over 2. So change my input from S to A. So that will be A minus 2 all over A plus 1. And they told me my output is 1 over 2. So this is just straightforward. Cross multiply. That will be 2 multiplied by A minus 2 is equal to 1 multiplied by A plus 1. So that will give me 2A minus 4 is equal to A plus 1. So I'll take this to the other side to become 2A minus A. Then this to the other side, that will become 1. It will become plus like that. So 2A minus A is A. 1 plus 4 is 5. So meaning A is equal to 5. So this we are asked to find the value of f of x is equal to 2. So that is when my input is x. So that is my output is s minus 6x plus 10. My output, which is f of x, is equal to 2 at that point. So this is 10. So I'll take 2 to the other side to become s squared minus 6x. Then plus 10. This will turn to minus 2. That will be plus 10 minus 2. That is 8. Is equal to 0. So you have to find the factor. So you can use your calculator, but I already knew that my factor is minus 4x minus 2x plus 8. So if you factorize this in a nutshell, you are going to get 2, 4 to save our time. So this is your factor. So your s can be 2 or 4. This determines the value of A if f of A is 5. The same approach. When your input is A, your output is 5. So your input is A now. You replace your x with A, then s minus 1, then your output you equate it to 5. You must multiply 5 times s minus 1. 5 times s will give me 5x. Minus 1 times 5 will give me minus 5. Then it's equal to, okay, this is A. Yeah, so 2A plus 3. Then 5A, take minus 2A to the other side and take 5 to also that side as well. So that will give me 3A is equal to 5 plus 2. Is it 5 plus 2? Hope no mistake. But this, yeah, 5. Yes, that is correct. That is 7. Then I divide both side by 3. So my A is 7 over 3. So the answer is 7 over 3. Of course, maybe there's an error somewhere. Let me cross check again. So 2x plus 3. Okay, 2A plus 3 all over A minus 1 is equal to 5 all over 1. Then I cross multiply. That is 2A plus 3. The same thing as 5A minus 5. Then I take 5 to the other side. Okay, this is 3. So 3 plus 5 was supposed to give me 8. Then 5A minus 2A. So that will give me 3A. Then 3 plus 5 is 8. Then I divide both side by 3. So A is actually 8 all over 3, not 7 all over 3. So the next question. Okay, we have finished this part. So let's start with limit.